Hi students, now the topic is standard hydrogen electrode SHEC, standard hydrogen electrode. Okay, so in galvanic cell or electrochemical cell contain two half cells. Total cell potential is calculated by using voltmeter, but we need to find out half cells of the potentials. For example, what is the potential of anode half cell and what is the potential of cathode half cell? Okay, so that cannot be found out. So the potentials of individual half cells cannot be measured, but by using SHE, standard hydrogen electrode, individual half cell potential can be calculated. So SHE is represented by platinum solid oblique H2 gas oblique H plus. So this electrode SHE electrode is prepared zero potential at all temperature corresponding to reactions. So it contains zero potential. So we are going to discuss about standard hydrogen electrode and its representation. Standard hydrogen electrode. The structure of the standard hydrogen electrode is like this. So this is a glass vacuum. It contains the platinum electrode, and this platinum electrode is coated with a platinum black, and we are using such metals like platinum, Rm. So these are inert electrodes. Because of these are not involved in the reactions, but they are allowed to pass the electrons. That means they are allow the oxidation reduction reactions, but they are not involved in the reaction. So they are allowed to flow the electrons from the these electrodes. Okay, like platinum and gold. Okay, platinum and gold. Now we are using platinum electrode in this, and this electrode is connected to the other electrode, and in this electrode from this way H2 gas is passed through this way, and H2 gas is bubbled through this way, or H2 gas bubbled through this way, and the solution contain acidic solution, 1 molar acidic solution, and these are 298 Kelvin temperature is there. So at all temperatures the standard hydrogen electrode potential is 0. Okay, but we are maintaining the standard conditions for this electrode. So this is a standard hydrogen electrode, and this electrode is connected to the another one of the off cell electrode. For example, you take the copper electrode. This is we taken as a cathode, and this is we taken as anode. Okay, anode. So both are connected, and one of the this is a voltmeter is present. So how much amount of the potential is produced, that is calculated by using voltmeter. So this electrode is dipped in this acidic solution, 1 molar acidic solution. So the concentration of both reduced oxidized form and oxidized forms of the hydrogen is maintained at unity value. Okay, so the pressure of gas is in this 1 bar pressure is there. Pressure of gas 1 bar pressure, and the concentration of this one is 1 molar at 298 Kelvin temperature. Okay, so this is a standard hydrogen electrode structure, and this standard hydrogen electrode is connected to the another one of the off cell. For example, we calculate the cathode potential. Okay, so cathode electrode potential. So cathode electrode potential in this cathode electrode potential. So we are going to calculate this off cell electrode potential. So this potential of this electrode potential of this cathode. So which one is there in this electrolyte? Copper sulfate. And what is the electrode? Copper. Okay, so it is act as cathode. And which of the reaction is take place in this? Reduction is take place. So this is a reduction of cell. This is a oxidation of cell. So oxidation is take place in this, and reduction is take place in this. Okay, construction of this cell. So there are reactions are take place in this. So oxidation is take place. Oxidation is take place. That means electrons are going to move from this electrode to this electrode. Okay, so moving of electron like this, flow of electron. Opposite of the flow electron is current. This is the current. So that is calculated. How much amount of the volts is calculated by using voltmeter. Okay, so in this copper plus 2 by gain of 2 electrons is converted to the copper solid. copper solid is deposited in this electrode. Okay, so from this Cu plus 2 ions. Okay, so the cell representation. So in this platinum solid by H2 gas by H plus, and this is a, what is this? Salt bridge made with KCl, and this cathode which one is there? Cu plus 2 by Cu. So Cu plus 2 is aqueous condition. So this is a galvanic cell representation or electrochemical cell representation, and we need to calculate cathode potential. So cathode potential calculated. So we take this is a net potential is appeared in this total cell potential. So that is a E naught cell equal to E right minus E left. So which one is the E right? This one. Which one is the E left? This one. So E naught cell, for example, total E naught cell value is given as 0.34 volts. We get 0.34 volts of the potential is appeared. But E right, we don't know E right value. So you take X minus, and E left value is, we already mentioned, E left value is 0. So X equal to 0.34 volts. So what is that X? ER equal to 0.34 volts. So which one of the value? This one, this value. So by using of standard hydrogen electrode, we calculated potential of this cathode. So what is the cathode? Copper electrode potential is calculated. So copper electrode potential is, what is that? 0.34 volts. So this is a reduction potential. So reduction is take place in this. The reductions are take place by this copper. Positive reduction potential is appeared. Okay. We need to calculate this off cell electrode potential. Okay. So in this this is taken as cathode, and standard hydrogen electrode taken as anode. So in this, like this. So this is a cell construction, and this is a cathode. Which one? Zinc electrode. And what happened in this oxidation? What happened in this reduction? So we observed this is anode, oxidation is take place, and this is cathode, reduction is take place. So this is a platinum electrode, and this is a inert electrode, and electrons are going to move from this electrode to this electrode. The flow of electrons take place. Opposite of the flow of electron is current. Okay, we already discussed that. And so the moving of electrons are take place from this. So electrons are gained by the zinc. So its reduction potential is there. Reduction is take place in this. Reduction potential is present in this. So we represent the electrochemical cell representation as like this: platinum solid by H2 gas by H plus, and this is a salt bridge representation, and Zn plus 2 by Zn. Okay. So if we take the E naught cell equal to E cathode minus E anode. So that net potential value is calculated by using voltmeter. So E naught cell equal to ER minus E left. Okay, ER is a cathode, E left is a anode. This one, right side. This is left side. So E naught cell equal to Zn plus 2 by Zn, and E H2 by H plus. So E naught cell equal to ER minus E left. So E naught cell value is calculated in that in that electrochemical cell minus 0.76 by the voltmeter. So minus 0.76 equal to ER is, we don't know ER value, so that is X, and EL value is standard hydrogen electrode value, potential value 0. So X equal to minus 0.76 volts. So this is a negative reduction potential value, negative reduction potential. So why it is get the negative reduction potential? Because of the zinc is involved as oxidation, involved in oxidation reactions. So that is the reason it is get negative reduction potential values. Okay, and the cathode is get the oxidation, cathode is get the reduction, so it get the positive reduction values. So 0.34 ER minus EL value is 0. So ER equal to 0.34 value, 0.34 volts. Okay, so this is zinc electrode potential, Zn plus 2 electrode potential, reduction potential or reduction potential, that is minus 0.76 volts, and this is a Cu plus 2 reduction potential, that is plus 0.34 volts. Copper plus 2 is by gain of 2 electrons, it is converted to the copper. So reduction is take place by this one. So that means it is act as a oxidizing agent, and Zn is converted to the Zn plus 2 electrons. What is mean of that? It is act as, in this oxidation is take place. Oxidation means it is act as a reducing agent. Okay, so it is a reducing agent, it is a oxidizing agent. Solid plus 2 Ag plus gives rise to Cu plus 2 and 2 Ag. Okay, so this is in this also we calculated what is that, E naught cell equal to E right minus E left. Okay, so for example, we don't know E, this we don't know E, this potential and this potential. So we go for the standard hydrogen electrode. So we take the standard hydrogen electrode. So construct the standard hydrogen electrode with this half cell, and construct the standard hydrogen electrode with this half cell. Okay, so we get every one half cell potentials. So for example, we get the 0.34 value of this one. We already know the plus 0.34, copper is a plus 0.34 volts, and silver is a Ag plus condition, Ag plus. Ag plus is a plus 0.80 volts. So you calculate the total E naught cell equal to E right minus E left. So in this, which one is cathode, which one is anode? Cu is converted to the Cu plus 2. So Cu is converted to Cu plus 2. In that, liberation of 2 electrons is there. So that means it is act as a anode. So why? It is in this oxidation is take place. Cu is converted to Cu plus, loss of electrons. Ag plus is converted to the Ag. What happened in this? Electrons are gained by the Ag. Okay, 2 electrons are gained by the Ag. We get Ag. Ag plus is converted to the Ag. So this is a reduction is take place. So reduction take place. This is cathode. So we take the E right. That means E right is a cathode minus E left. E left is a anode. So we take the cathode potential value is the cathode potential. Cathode, which one is this one? So plus 0.80 volts minus, and anode potential is 0.34 plus 0.34 volts. So we get the total value 0.80 minus 0.34, 6, and 7 minus 3, 4. So total net potential is 0.46 volts. Okay, by this following this way we calculate the E naught cell. This reduction potential values. So reduction potential. Reduction means it is going to obstruct the electrons. So F2 plus 2 electrons is going to form 2F minus. Ft is going to obstruct the electron easily. So that is the reason it is a high positive value. 2.87. So reduction is take place by the F2. That means it is act as oxidizing agent. So that is the reason. So it is increasing strength of the oxidizing agent. So it is a more oxidizing agent because of reduction is take place. Which one is going to involve reduction? That is act as oxidizing agent. Which one is going to involve oxidation? That is act as reducing agent. So you observe in this lithium plus. Actually lithium is a metal, first group metal, lithium. So it does not going to obstruct the electrons, and that means it is not ready to obstruct the electron from other one. So if the electron is gained by this lithium plus 2 plus electron, we get the lithium solid, but it is we get the reduction potential is minus 3.05. So in this what happened in this reduction is take place. So it is also act as oxidizing agent, but minus 3.0 value. So why it is get the minus 3.0 value? Because of it is a first group element. So first group elements are going to lose the electrons. In this lithium plus plus electron, we get the lithium solid. So reduction is take place. In this also reduction is take place. So we get the minus 3.05 value. Why we get the minus 3.05? Because of it is going to lose electrons, but it need not to take electrons. If the electron is gained by this, we get the minus 3.05 values. So that means it is a reduction is take place. It is also act as a oxidizing agent, but very low value. Okay, less oxidizing agent. But we observe in this increasing strength of the reducing agent. So in this it is act as a powerful reducing agent. Because of it is going to lose electrons. Reducing agent means oxidation is take place. Oxidizing agent means reduction is take place. So in this, which one is take place? Reduction, but it is very less value. So actually lithium is converted to the lithium plus electron is why it is take place like this? Because of the lithium is a first group element. Okay, so by losing of one electron, it is stabilized with a noble gas configuration. Okay, so what is the mean of that? The first group and second group elements and some metals have less. That means these are some metals, first group and second group element, first group and second group metals, and some of the D block elements contain minus reduction potential values. So you observe in this minus 3.0, minus 2. Minus 2.7, minus 2.3, minus 1.6, minus 0.83, 0.76 like this. So the minus values is there. That means these are act as reducing agents. Why? These are involved in oxidation reactions. Okay. So powerful reducing agents. So the reducing nature character is increases from this. Lithium is strong reducing agent. Okay. So you observe in this H2 hydrogen gas is a 0.00. So it is a zero value. Reduction power is of the hydrogen is 0 value. Okay. So and next fluorine is high oxidizing agent because of reduction is take place. Abstraction of electrons take place by the fluorine easily because of it is going to absorb the electron from the another one. It is going to stabilize noble gas configuration. So that is the reason we get the positive value. Okay. So this is a standard electrode potentials at 298 Kelvin temperature. And next one is Nest equation. In this Nest equation, the electrode potential at any concentration measured with a standard hydrogen electrode, but it can be represented particular formula. And before that, this definition, the relationship between the concentration of ions and electrode potential is given by Nest equation. Okay. So the relationship between the concentration of ions and the electrode potential, that is given by Nest equation. Okay. What is the meaning of that? Electrode potential of at any concentration with respect to standard hydrogen electrode can be represented by using N plus N is a oxidation state, Mn plus by gain of N electrons we get M solid. So reduction is take place. So reduction potential is there. Okay. So we represent for this one E electrode potential E Mn plus by M equal to E naught Mn plus by M minus RT NF Ln concentration M by concentration Mn plus concentration metal by concentration of metal ion. Okay. So this is the formula. Which formula this? What is the formula? This is a Nest formula. Okay. So electrode potential equal to E naught of the metal minus RT by NF Ln metal by metal ion. Okay. So but concentration of solid is M is taken as unit value. So we take the M value is 1. So equal E Mn plus by M equal to E naught Mn plus by M minus RT by NF Ln, m value is taken as unit value, solid concentrations. So 1, you take the 1 by m and plus. Okay, this one. Inert cell already is been defined. R is a gas constant. Okay, so and F is a Faraday, that is 96500 coulombs. R is gas constant 8.314 joule Kelvin inverse mole inverse. Okay, this is a gas constant value, and Faraday, F is a Faraday, F equal to 96487 coulombs mole inverse. Okay, so and T is a temperature in kelvins. Okay, and Mn plus is a metal ion concentration. For example, we take the Daniell cell. So that is a Cu plus Zn, Cu plus 2 plus Zn gives rise to the Zn plus 2 plus Cu. So this is a one of the Daniell cell or galvanic cell or electrochemical cell. What is happening in this? Cu plus 2 converted to Cu, Zn plus 2 converted to Zn plus 2. So what happened in this? Electrons are ruled by Zn. So it is a oxidation is take place. Electrons are gained by Cu, reduction is take place. So we write the next equation for this one. Daniell cell electrode potential for any given concentration. For the Cu plus 2 ion and Zn plus 2 ion, we write the next equation for the Cu plus 2 ion, for the Zn plus 2 ion. As per that, so in that, which one is this is reduction. So this is a cathode and this is a oxidation. This is anode. And we take the cathode point of view. Cathode. So what is the cathode in this? Copper, Cu. So Cu plus 2 by Cu equal to E0 cell. E0 Cu plus 2 by Cu minus RT NF Ln 1 by which one? Cu plus 2, metal ion. Okay, Cu plus 2. So Cu plus 2, this is the aqueous condition is there, Cu plus 2. Okay, so this is a cathodic next equation representation. For the anode, we take the E Zn plus 2 by Zn equal to E0 Zn plus 2 by Zn minus RT NF Ln 1 by Zn plus 2. Okay, so this is also aqueous condition. This is for the anode. And the cell potential, E cell equal to E cathode minus E anode. So or E right minus E left. We all know that one. So in that, which one is cathode? This one. Which one is anode? This one. So we substitute these both one in this. E cell equal to E cathode minus E anode. E cell equal to E0 Cu plus 2 by Cu minus RT NF Ln 1 by Cu plus 2. So this is a cathode. Minus, that what is this? E R minus E left. E cell equal to. This is the formula. So E right is this one. E cell equal to this is a cathode. That means E R minus EL. EL which one? Anode. So you take E not Zn plus 2 by Zn minus RT by NF, same Ln 1 by which one? Zn plus 2 ion. Okay, aqueous condition. So we rearrange this. Take the E naught cell Cu plus 2 by Cu minus E naught Zn plus 2 by Zn. So you take this conversion to this plus value, this minus value. So E naught Cu plus 2 by Cu minus E naught cell E naught Zn plus 2 by Zn. Okay, minus RTNF. Okay, RTNF okay, RTNF multiply to the ln 1 by Cu plus 2 minus ln Zn plus 2. So you observe in this log A minus log B, log A minus log B, ln A minus ln B. But in this log A minus log B, you take the log A minus log B, RT by NF, RT by NF, log A minus log B, you take the ln A, which one is the, this one, 1 by Cu plus 2 by log B, 1 by Zn plus 2. You get RT by NF ln. So you are rearrange this Zn plus 2 by Cu plus 2. You get, okay, minus, and you take the same, these are, that is equal to E naught Cu plus 2 by Cu minus E naught Zn plus 2 by Zn. E naught Cu plus 2 by Cu minus E naught Zn plus 2 by Zn. Okay, so this is a next equation. Next equation for the zinc and copper ions. Okay, and E cell depend on the concentration of both Cu plus 2 and Zn plus 2. Okay, so you directly take the E cell of the E naught cell of the Cu and E naught cell of the zinc. You directly take the E naught cell minus and RT by NF ln Zn plus 2 by Cu plus 2, concentration and concentration. So you observe in this E naught cell minus R value, R equal to 8.314. Okay, and T is a temperature, 298 Kelvin temperature, 298 Kelvin temperature T. How many electrons are liberated by the zinc and how many electrons are absorbed by the copper? 2 electrons. N equal taken as 2 electrons. Okay, and F is a 96487 coulombs. F is 96487 coulombs. Okay, and remove the ln. So you take the R, T, NF. So removal of ln. So we introduced 2.303 log Zn plus 2 by Cu plus 2. Okay. So you get we substitute these values, R value, T value, N value, F value. So you get the E naught cell, E cell equal to E naught cell minus RT 0.8314 into 2.303 by 2 into 96487 log Zn plus 2 by Cu plus 2. Okay, you get E naught cell equal to 0.059 by 2 log this 2 log Zn plus 2 of by Zn plus 2 concentration by Cu plus 2 concentration. Also you write the E naught cell minus E cell equal to E naught cell minus 0.059 by 2 log. So Zn plus 2 is which one? Cathode or anode? Anode. So anode concentration by cathode concentration. So if the any electrochemical cell, any galvanic cell representation, so you take the anode ion in this, cathode ion in this. Okay, anode ion in this, cathode ion in this. So it is going to find out easy. For example, solid by nickel plus 2 with salt bridge Ag plus by Ag. And that this right side is cathode and left side is anode. We all know that one. What is the reaction in this actually? Nickel plus Ag plus gives rise to the nickel plus 2 plus Ag. What happened in this? Nickel is going to lose 2 electrons, but Ag is going to gain 1 electron. So you balance this by using 2 in this, 2 in this. Okay, so it is balanced. How many electrons liberated? 2 electrons. So this is a reduction. Reduction or oxidation. And how many electrons gained? This one, 2 electrons. So this is a reduction. Okay, so this is a cathode. That's why we taken in this right side to this, in this galvanic cell representation. And this is a oxidation, anode, and this is taken as anode, right side, left side. Okay, and we substitute these ions. So what are the ions? Cathodic ion. What is the cathode ion? Cathode ion is Ag plus. What is the anode ion? Anode ion is nickel plus 2. Okay, so you take the E cell equal to E naught cell minus RT NF Ln anode by anode concentration, anode ion concentration by cathode ion concentration. Okay, or you substitute this E naught cell minus RT NF log Ln anode, which one is there? Ag plus. Cathode, which one is there? Cu and nickel plus 2. Okay, nickel plus 2. So this is easy way. Or also you directly directly substitute in this by the removal of R value, T value, F value. Okay, how many electrons are utilized in these 2 electrons? So you take the E naught cell minus 0.059 by 2 log Ag plus concentration by nickel plus 2 concentration. Okay, so we calculate the E cell of the galvanic cell easily by taking of the concentration of this electrode and concentration of this electrode. In next equation, the electrode potential is going to calculated at any concentration of the electrodes. Okay, with respect to the standard hydrogen electrode. Equation for the magnesium solid plus 2 magnesium solid plus Ag plus gives rise to Mg plus 2 plus Ag. Okay, so this is a reaction. First of all, this is a reaction. First of all, you write the galvanic cell equation. So, okay, galvanic cell equation. Before that, you balance the ions. Mg is going to form Mg plus 2, but Ag plus is converted to Ag. How many liberated? 2 electrons. How many abstracted? 1 electron. So you take, multiply with 2, that is 2 Ag plus and 2 Ag in this. Okay, 2 electrons, it is balanced. And write the galvanic cell equation. How to write the galvanic cell equation? So left side is taken which one? Anode. In that, which one is anode? Which one is reduction is take place? That is cathode. Which one is oxidation take place? That is anode. And oxidation, this is a oxidation. This is anode. And this is a reduction. This is cathode. So we find out the anodic electrode and cathodic electrode. Anode ion and cathode ion. Okay. Anode ion and cathode ion. So we write the galvanic cell representation. How to write? Left side is taken anode electrode. Right side is taken cathode electrode. So Mg by Mg plus 2. This is a, what is this? Salt bridge. Ag plus by Ag. So this is a galvanic cell representation. And write the next equation for this one. Next equation, E cell equal to E naught cell minus RT, NF, Ln, anode concentration by cathode ion concentration. Okay, that which one is anode, which one is cathode? This is a anode ion. Anode ion. What is the anode ion? Mg plus 2. What is the cathode ion? Cathode ion Ag plus. So you substitute the anode ion 1 and cathode ion 1. And also you read the removal of this log and RT values, RT NF values. E0 cell equal to 298 Kelvin temperature. You take the 0.059 by how many electrons you utilized in these 2 electrons? 2 log anode concentration by cathode concentration. Okay. So this is a next equation. So we calculate the concentrations of the anodes and cathode easily, and also calculate the E cell of this galvanic cell easily. For example, you take the concentration of magnesium, that is Mg plus 2 concentration is 0.130 molar, and Ag plus concentration is 0.001 molar. Okay, so these are a concentration, and we already know the E naught cell equal to 3.17 volts, and calculate the E cell. Okay, so this is the E naught cell value 3.14 volts, and calculate the E cell. So you substitute the E naught cell value, and already 0.059 by 2 already, because of the 2. What is the 2 means? What is that? N value is 2, because of N is how many? 2 electrons. And log anode what is this? 0.130 molar, and concentration of the cathode is 0.01 molar. Okay, so you substitute these values in this, calculate the E cell. Okay, this is your question.